Alright, picking back up. We're going to go over here. We're going to upload this. This is going to be this whole process that we've outlined just in the previous video. Right up to the end. We're coming right up against it in seconds. This is going to be complicated. This is I'm not, you know what, I'll be honest with you, I'm not entirely sure we're going to be able to pull this off, but this is just, you know what, I'm recording the videos, I'm uploading them literally in the next video in front of you, so you know that, you know, if we get this done, that's great. If we don't and we fail miserably, then to hell with it. Maybe someone will learn something from it. So let's think about this. How are we even going to start to approach this problem? Well, the basic approach that we're going to take is, as we talked about, we're going to think about it in terms of x equals 5. What's really going on is that x equals some memory value, and that equals 5. It has some constant over here. So if we hit enter, obviously this wouldn't make any sense, but Python would say, hey, I don't know what the hell you're saying, syntax error, yada yada yada. What's really going on here is that there's a variable, there's a memory location. The memory location has value. So how are we gonna do this? We're going to reverse this process. We're going to go from, instead of going from, in the programming language here, instead of going from variable name to value, we're going to reverse this process with the cheat engine, and we're going to go from value to variable. So we're going to make a variable. So are we going to set the value to 5? No. We're going to set the value to something crazy. 9473203. If we have to reset this variable, we're going to have to shut this down and restart it or whatnot, because we're specifically looking for the value of the first variable declared inside the process of this Python interpreter. Wherever this Python interpreter is loaded in memory, who gives a shit? But what we're looking for is the address. Let's rephrase that. What we're looking for is the memory location of the first variable relative to this process, which is the Python 2.7.5 shell. So how are we going to do that? We're going to make the first variable. We're not going to make any more variables because we're only concerned with the first one. We're going to give it some crazy bit pattern. What is this in binary? I have no idea. But Cheat Engine will figure it out. It has some automatic function or some translation conversion stuff. Again, we're going to select the second process. We're not going to spend a whole lot of time on this kind of stuff. We got to start zipping through this, or we're going to be here forever. So what are we looking for? 9473203. I know out there right now there are some people listening and watching this saying there's absolutely no fucking way that this is gonna work. It's possible they're right, but whatever. We're not gonna do that. So let's use a feature of Cheat Engine that we have not really gotten into yet. We're gonna say we're gonna do the pointer scan again. Is there a manual way that we can start digging for pointers? Yes, there's absolutely a way that we can do it, and we will, as soon as we're done, sort of exploring the more general idea of pointers and whatnot, and seeing that the pointer scanner really does abstract away multiple levels of indirection. As soon as we can prove that concept, which we're doing right now, if this is a successful thing, then we will have proved beyond any reasonable doubt that we are absolutely not talking out of our ass, and that this is real stuff. And so once we're done that, then we'll jump into the sort of the more manual way. And that's all I'm gonna say about that. So we're gonna right click anywhere. Again, we kind of went over this. We right click there, we can right click there, anywhere. Right click anywhere on the record. Well, let's first just make sure that we have it. Let's zero it out. What is the value of x? According to Python, it is in fact 0. We know the values that were poking into that memory location in Cheat Engine are in fact being reflected in Python. We have the right value. We're going to do a pointer scan. What is a pointer scan? So we're going to close the pointer scanner. What is the pointer scanner? The pointer scanner, in a nutshell, in a very general sense, is something that will go through, you're linked to a process already with Cheat Engine. You go to Cheat Engine, you say, I want to do a pointer scan. What is Cheat Engine doing under the hood? There's a whole lot of crap that it's doing under the hood, but in a general sense, what it's really doing is it is going to pretty much take the whole memory space of the process that it is attached to, and it is going to scan for memory locations that have values of the address that we have selected here. So again, remembering what a pointer is in the previous videos, what is a pointer? It is a variable that has a memory location, and that memory location refers to, references, points to, whatever you want to say, another location in memory. So we're reversing that process and saying we know what the location that the pointer is pointing to, or the pointers that we are looking for points to, and then we want to go from the value of a memory location that points to this address, we want to go back to that memory location that points to us. And then, if necessary, we want to go back to the one that points to that, and then we want to go back to the one that points to that. And we want to basically collapse all the levels of indirection that have been set up by the developers of the application until we get to some level where we are confident, or cheat engine has some sort of rules that determines whether it's confident in that or not. And that maybe that's something we'll get into, but for the purposes of this video, we're just going to say that the pointer scanner is collapsing levels of indirection via pointers until it gets to some level where it's comfortable that, let's return this is a valid result. It's possible this might be what the user is looking for, so let's give them back this pointer. Now, is it only going to return one level pointers where it's a pointer to a memory location to a value? Absolutely not. We are going to be able to use the pointer scanner and let it know how many levels of indirection we want it to collapse. We're not going to get crazy. We're going to leave it at the default value, which I want to say is 5. But in a nutshell, that's what the pointer scanner is going to do. It's going to take multiple levels of indirection, it's going to collapse them all down, and it's going to return a massive set of results so that we can sort of restart the process and fiddle around with values. In our case, it's going to be the Python interpreter, but the Shadowrun game would and any application is just as valid. Collapse those levels down by manipulating the application and data in the application, and then rescanning those results until we get to some level where we can start screwing around and say, as a user, we can start checking the values and in some manageable way. We'll get down to, probably, if I had to guess, maybe like 5,000, maybe 300. I don't know. We'll see what happens. But that is in a very, 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 very brief nutshell, that is what the pointer scanner is going to do for us. So we're going to right click on this value. We're going to go to pointer scan for this address. We're going to sort of stop for a second and look at this. This is definitely exploding as far as time goes. But again, the pointer scanner is something that you can use to find most pointers in the game. So we are going to sort of slow down here a little bit. We're going to act like Congress. We're going to slow way the hell down. We're going to sort of go over some of these things. And there's are we going to go over every single one in incredibly pedantic detail? No, because that's something that in later sort of appendix videos, maybe I'll break it out and you'll be like, this is what this means. But anyway, what's the address that we're looking for? The address, you can see it auto-populates the address that we're looking for with whatever we had right-clicked on down here. So what does this mean? What this is saying is the address, the pointer for the first or the last level of indirection, as the case may be. Because remember, when we were, adding an address manually, we can't bring it up right now, but when we were adding it, well, we'll just close it. When we were adding an address manually, we could add offsets. First, we're going to make it the pointer. We could add offsets. You see that as we were talking, there's the hyphen and the arrows here, and there's the brackets and whatnot, which is something I think we failed to mention in previous videos, where cheat engine is sort of pointing out to a haha, there's a nice pun. It's essentially saying to us that this is a level of indirection. This is a level of indirection. It's more indirection, yet more indirection. What are you doing? It's more indirection. Oh wait, you're done doing indirection. Here's a value. So what the pointer scanner is asking us as far as the address to find is what is the top level memory location that you want to find with the pointer scanner. So when you right click on it, that's why it auto fills it in for you. It's essentially saying to you, you want a pointer scan for this address. So on the very top level of me scanning for pointers, relative to whatever the depth or whatever the multi-level or the amount of indirection you want to collapse, this is the address that you want to search for. This is the pointer on the top level that you want to find pointing to this address. Does it mean that the pointer on the top level is going to have this memory location? No. It simply means that the pointer on the top level is going to have a value that points to this address. If you are in any way doubting the complexity of what pointers allow you to do in applications and programming and things like that, you should thoroughly have thrown that out the window and be unequivocally convinced that pointers quickly spiral out of control and we are way the hell out there in left field. And again, if you're not a comp sci major or something like that, these are concepts that you'll have no exposure to, and you're gonna have to listen and play with and fiddle with for some time before you really grasp it. And I'll be honest, I do I deal with pointers because I write Python code and stuff like that? No. Under the hood, do I deal with them? Sure. I occasionally write C code, and I clearly evidence by my extensive knowledge of hexadecimal and the embarrassment that was that video that there's arithmetic and more complex things when you start getting into that sort of stuff. Do I understand what I'm saying? Maybe kind of. Some people would make an argument about that, but these are complicated things, and so again, if you're in any way doubting the complication of this sort of stuff, then what we just said about the collapsing of multiple levels in direction, and some of the things that we're going to start talking about as far as the options here in the pointer scanner, then you should be absolutely convinced that this is complicated stuff. So we have address defined. We're not going to worry about value defined yet because it would be meaningless to us. Addresses must be 32-bit aligned. Not going to worry about that. Not going to worry about that. The next option, nope, nope. Heap data, nope, don't care. Looping pointers, nope. Stack addresses, definitely don't care about that. You know what? We're just going to skip that whole thing. Again, we'll come back, maybe deal with it. We're going to focus on these two options down here. The number of threads scanning, 2 to 5 is sort of the default, and the documentation about Cheat Engine and whatnot talks about how that's an optimized value for single and dual core processors. We happen to be running on a quad core. We'll set it to 8 because there are, technically speaking, there's 8 cores. Do they all run in, totally parallel fashion or whatnot? That's debatable, and frankly, I highly doubt it. But you know what? Fuck it. We'll leave it at 5. The max level, the offset level, 2048. We're not going to really talk about what the offset value is. We have already demonstrated what we mean by the offset value. Oh, god damn it. All right, we'll go back and talk about it. What does it mean when it says the maximum offset level? When we were messing around with pointers earlier, we'll just add a bunch of offsets right here. This is what it's talking about. It's saying, how far do you want me to check from the actual address that you're digging up? I don't know why we're doing it on the top level. Let's see if we can maybe prove the point here. 2040, that's a ridiculous offset. 2048, it is in fact allowing us to go higher, but we're adding it manually. I'm not sure, do I suspect that there's a limit for the manual pointer add? I don't know. Maybe not. No, it doesn't really seem to be. I don't know. Let's try FFFF. Let's click some stuff. It's, what, there's a ridiculous limit here. Who the hell, yeah, okay, so there is in fact some limit. What is it? It's a whole lot of F's. 4, 6, 7. I bet it's 8. Yep, you get up to 8 Fs. You get up to a 4-byte value that's maxed out. Cheat Engine is essentially going to say, I'm pretty sure you don't know what the hell you're doing, and it's probably going to roll back over to 1. There's actually a technical reason for that. If I had to guess off the top of my head, it's probably because pay no attention to the man behind the curtain if you want to what I'm about to say, but if I had to guess, it's probably because memory addresses are 4-byte values, and FF, 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 yeah, that's the max value. We can sort of prove this point. FF, 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 that's 6 Fs, that's 7 Fs. Let's do E. Does it let us do E? It does not. I don't. There's something to do with the rollover rules here, and I'm sure, again, I'm just being stupid, and I'm not thinking about it because am I under pressure in the sense that I'm on Who Wants to Be a Millionaire? No. But I'm under pressure in the sense that I'm recording this, and frankly, I don't really care about it. Or I mean, I care about it, but not in the context of the video. So we're going to go here. We're going to bring this menu back up. Go to pointer scan for this address. What is it saying by the max offset value? It's essentially talking about the offsets that we were just looking at right there. What is the max level? What the max level means is how many offsets are we going to apply to this what's the level of indirection that we're going to be searching for. So to sort of quantify that in some way before we run out of time here, let's do the add address manually. Make it a pointer. What do we got? It's a pointer. There's 1 level of indirection. Now there's 2. Now there's 3. Now there's 4. Now there's 5. That's essentially what that max level of the pointer scanner means. It says I'm only digging down 5 levels, and if you think that the pointer's any deeper than that, then either A, you're out of your mind, or B, you really better know what you're doing because it's gonna just wreck your computer searching for that level of indirection. So with that, we'll jump back into this and see if we can maybe get the show on the road here.